Hello and welcome. In this lesson, we will talk about disaster recovery options on Oracle Cloud Infrastructure. Disaster recovery is the method used by organizations to regain functionality after a disrupting event. It covers the methods and plan involved to restore the environment. The key metrics for disaster recovery are Recovery Point Objective, RPO, and Recovery Time Objective, RTO. RPO, Recovery Point Objective, represents the time between your last backup and the disaster event. You can also understand RPO as the amount of data that your company can afford to lose. RTO, Recovery Time Objective, represents the time that an application or system can be down without causing a substantial damage to the business. In this diagram, we list how cost changes depending on the desired RPO-RTO combination. The more RPO and RTO are aggressive, the higher the cost gets. Backup and restore would be the cheapest option in the proposed scenarios. The on-premises backup is sent to the cloud, and in the case of an event, the data is restored from OCI. In the standby option, the data is replicated to OCI and the minimal set of services are kept active on OCI. Data is replicated on shorter intervals, and as part of the infrastructure is already up, less data will be lost, and the recovery time will be faster, but the cost is greater than the previous option. When you set up the active-active option, the replication is performed on even shorter intervals, almost online, and that will reduce drastically the RPO. The system components are already created and active, ready to take over. The cost is higher than the other two, but it offers much faster results. OCI regions is the first component that we'll talk about. OCI regions are completely independent from other regions and are separated by vast distances, across countries or even continents. Use different regions to mitigate the risk of region-wide events like earthquakes, and also legal requirements as data sovereignty or legal jurisdiction. When you use different regions on OCI, virtual cloud networks on different regions can be connected using remote VCN peering. The resources will be able to communicate without leaving the OCI network. Let's talk about the best practice when creating block volume backups. When creating and restoring from backups, keep in mind the following. Before creating a backup, you should ensure that the data is consistent. Sync the file system, unmount the file system if possible, and save your application data. Only the data on disk will be backed up. When creating a backup, after the backup states change from request received to creating, you can return to writing data to the volume. While a backup is in progress, the volume is being backed up cannot be deleted. If you want to attach a restored volume that has the original volume attached, be aware that some operating systems do not allow you to restore identical volumes. To resolve this, you should change the partition IDs before restoring the volume. The steps to change an operating system's partition ID vary by operating system. For instructions, see the operating system's documentation. You should not delete the original volume until you have verified that the backup you created of it completed successfully. Disaster recovery for Oracle databases can take advantage of Active Data Guard or Golden Gate. Active Data Guard provides secure physical replication. The standby database is open read-only, so your data consistency is guaranteed. Simple, fast, one-way replication of a complete Oracle database. The default configuration handles most workloads, so there is little administrative overhead. If you want to implement more advanced replication features, the choice is Golden Gate. It replicates filters and transforms data from one database to another database. It enables the replication of data between Oracle databases and other supported heterogeneous databases. It can be installed on-premises or as a platform service on OCI. This concludes our lesson on disaster recovery on OCI. Thanks for watching and see you in the next lesson.
Hello and welcome. I'm Orlando Gentil.
Oracle University Instructor. In this lesson, I will present you to the Full Stack Disaster Recovery Service. Within a business continuity plan, disaster recovery consists of the step of the plan where critical business components are restored as quickly as possible after an unexpected disruption. The Full Stack Disaster Recovery is a service offered by OCI that enables orchestration and management of disaster recovery for all layers of an application stack. This comprehensive solution provides complete disaster recovery capabilities. Throughout the other lessons, you learned how OCI components are resistant and resilient. Now, with Full Stack Disaster Recovery, you will learn how to glue all those parts together, ensuring that all components of your stack are covered in case of a disaster event. Before we dive into Full Stack Disaster Recovery, you might be wondering why you need a disaster recovery solution. Let me tell you some of the benefits. Rather than focusing on recovery of the individual components like databases or compute instances, Full Stack Disaster Recovery offers recovery for the entire application stack. This comprehensive approach is important for ensuring business continuity, as the recovery of select components is not enough to guarantee the restoration of critical business functions. With Full Stack Disaster Recovery, the topology of deployment characteristics of diverse application stacks are assessed, and a dedicated disaster recovery workflow is automatically generated for recovering all components of the application stack in a different region. Full Stack Disaster Recovery removes the requirement for manual disaster recovery of individual resources within an application stack, including infrastructure components, middleware, databases, and application components. By leveraging fully automated DR workflows, the entire application stack can be swiftly brought up in a different region. A common problem with disaster recovery workflows is that topology changes, configuration changes, or environment drift can make disaster recovery workflows unusable because they do not match the environment they are protecting. Full Stack Disaster Recovery provides a comprehensive series of pre-checks that you can use to continuously validate the conformity of DR workflows with the application environment you configure them to protect. Disaster recovery workflows are error-prone as they require a complicated orchestration of many precise interconnected steps to be performed by humans. Full Stack Disaster Recovery automates and sequences these steps to provide fast and seamless disaster recovery operations across regions without human intervention, thus reducing disaster recovery workflow errors. Full Stack Disaster Recovery workflows are highly flexible and customizable. You can adapt them to perform DR for any application stack or a set of IT assets. You can add your own callouts and custom logic to any workflow and precisely configure the action of these customizations. The operators and administrators do not require any special skills or domain expertise in areas such as applications and storage replication. You can create and test DR workflows ahead of time. This process eliminates the need for experts when performing the DR operations. Full Stack Disaster Recovery provides a single pane of glass monitoring and managing capability for all disaster recovery needs. You can create a DR protection configuration, monitor DR readiness, execute DR workflows, and manage errors using the OCI console. Now that you know some of the benefits, let's take a look at the features. Full Stack Disaster Recovery encompasses not just infrastructure, but the whole stack. It runs as a service, allowing you to focus on the plan and not in conversion servers, Bastion, or any kind of resource that is not directly part of your stack. Each DR protection group is independent and can manage completely different DR strategies and deployment architectures to meet different SLA requirements. Although not required, full-stack disaster recovery can manage disaster recovery for infrastructure. It can work with any combination of instances, databases, and applications. Configure, manage, initiate, control, and monitor disaster recovery operations, including switchovers and failovers between regions using the OCI console, the CLI, or API from anywhere around the globe. Fully automated DR operations allow executives and management to rest a little easier since there is no need to assemble a cadre of storage, network, database, and application specialists to begin a DR operation, perform tasks at key moments, or shepherd the recovery process all hours of the day. Bring part or all of a business back online faster after a catastrophic event simply by selecting a specific DR plan from a list of plans in the OCI console. Full Stack Disaster Recovery Service uses custom intelligence to generate DR plans for Oracle applications and infrastructure. This helps customers generate basic DR plans very fast with very little effort on their part. Customers don't have to spend time figuring out what actions need to be completed during a DR transition or spend time adding common OCI services to DR plans. Customers can add, remove, modify tasks, change their order, and add or remove custom automation to complete the DR plan at any time. Visually observe a DR operation every step of the way through the OCI console. Full Stack Disaster Recovery Service allows a switchover or failover to be cancelled, paused, and resume at any point during the execution of a DR plan. Drill down into comprehensive, high-detailed logs during and after the DR operation. Full Stack Disaster Recovery performs comprehensive pre-checks before a DR plan is executed to ensure the DR operation succeeds at the standby region. A passive, non-disruptive pre-check can also be run at any time without executing the DR plan. Now that you know what Full Stack Disaster Recovery Service is, its benefits, and its features, jump to the next lesson and know in detail the components and prerequisites. Thanks for watching and see you in the next lesson. Hello and welcome. In this lesson, I will talk about the Full Stack Disaster Recovery Service components and what do you need to know about each one of them. Let's get started. The first thing you need to know is which OCI components are supported. Supported in this case means that they have built-in automations that you can use. As I speak, several other components are having their automations being built. Always check the documentation for the most recent list. If the component is not on the list, it can still be added using custom automations. The next thing you need to know is your application stack. Create a consistent grouping of these application components and dependencies. The first and core component of FSDR is the Disaster Recovery Protection Group, or DRPG for short. Remember the grouping you established while defining your stack? The DRPG is the component that will represent your stack. DRPGs are defined in pairs in a peer relationship. One DRPG will have the primary role and the other will have the standby role. Within the DRPG, you will have the members. The members are the OCI components that are part of your stack. The next component is the DR plan. The DR plan represents a DR workflow associated with a pair of disaster recovery protection groups. There are two types of DR plans: switchover and failover. The switchover DR plans performs a planned transition of services from the primary DRPG to the standby DRPG, while the failover DR plan performs an unplanned transition of services to the standby DRPG. DR plans are defined in the standby DRPGs. Inside the plan, there are plan groups that I will give more details in the next slide. Before going into the plan group, let me do a quick recap on how the components are lined up. On FSDR, you will have the primary and the standby disaster recovery protection groups associated. Next, you will have the disaster recovery plan. It can be switchover or failover. Inside the DR plan, there will have one or more plan groups. The plan groups hold the plan steps, a single indivisible execution unit in a DR plan. Plan groups obey a sequential order, while the plan steps within are executed in parallel. The groups and the steps can be built-in or user-defined. A built-in group or step is generated automatically by FSDR when a DR plan is created. Examples of built-in plan steps are launch compute instance, switchover databases. The user-defined groups or steps are added to the DR plan after FSDR creates the DR plan. Examples are to start and stop an application using scripts or call out an OCI function. In this lesson, I showed you the FSDR components and how they relate to each other. In the next lesson, I will show you how it looks like to set up FSDR in the OCI console and how each of the components are added. Thanks for watching and see you in the next lesson. Hello and welcome. In the previous lessons, you learned about the features and components of the full-stack disaster recovery service. In this lesson, I will present you the sample scenario that will be used in the demos. This scenario will show all the features of the full-stack disaster recovery service. Please take this as a reference of the service capability, but have in mind that we are just scratching the surface. The full-stack disaster recovery service can handle any size and type of stack in a variety of disaster recovery strategies. Let's get started. Now that my stack was identified, let me show what are the prerequisites that the scenario must have. First, the volumes need to be part of a volume group. It will make it easier to set up the replication later. A bucket for the full-stack disaster recovery service logs is also required. Continuing the list of the prerequisites, I have to recreate the network components in the standby region. If you are using Terraform and Resource Manager, that can considerably speed up the process. Once the network is mirrored in the standby region, I have also to set up Object Store Replication, Autonomous Data Guard, and Block Volume Replication. For the block volumes, it's either replication or cross-region backup copy. After those steps, the actual full-stack disaster recovery service setup can start. This concludes this lesson, and you are ready to jump into the demos and see from start to finish how the setup and DR plan execution is done. Thanks for watching and see you in the next lesson. Hello and welcome. Now that the prerequisites are in place, let me jump into the OCI console and start setting up the components according to what I need for my MuleShop scenario. First, I will create the DR protection group in the primary region. Ashburn will be my primary region. Using the console, on the navigation menu, I will select Migration and Disaster Recovery and then DR Protection Groups. Clicking on the Create DR Protection Group button, the creation dialog will prompt for the name of the group and the compartment. Remember in the prerequisites when I mentioned an object storage bucket for the full stack disaster recovery service logs? That bucket will be selected here. The role and the members will be defined later. The creation process takes around a minute. Throughout this video, some sequences might be displayed in a faster speed and sometimes without audio. Some sequences will also be shortened to exclude waiting time. Once the first protection group creation is finished, I will move to the other region and proceed to create the second protection group that will be the standby one. My standby region will be Phoenix. After changing the region, I will repeat the same steps and create the DR protection group, entering the name, the compartment, and selecting the object storage bucket for the logs. With the DR protection groups created, I will establish the peer association and define the DR protection group in the Ashburn region as the primary and the one in the Phoenix as the standby. As my last action was to create the DR protection group in Phoenix, I will switch back the region to Ashburn and click on the DR protection group there. On the Details page, I will click on the Associate button, select the role, primary in this case, pick up the region where my peer DR protection group is located, Phoenix, and as it was created in the same compartment, the Phoenix DR protection group should appear, and I will be ready to click on the Associate button. When the peering is finished, the label Primary will be displayed near the Ashburn DR protection group name in the Details page. When I switch the region to Phoenix, the DR protection group for that region will have the standby label displayed in the role column in the list of the DR protection groups. After the DR protection group association is completed, I will add the members of the protection group, selecting the components of my stack that are the instances, storage groups, and autonomous databases. I'm creating a cold standby DR, so in this case I will not include the compute instances in the standby DR protection group. To add members to a DR protection group, I will go first to the DR protection group in the Ashburn region and click on the DR protection group name. Under Resources, I will click on Members and then on the Add Member button. First, I will add the Autonomous database. Select the resource type. Autonomous database is what we want. Anytime you add or remove a member, existing plans will be deleted, so it is required to acknowledge the warning, and then I will select the database that I will add. It's possible to follow the progress clicking on Work Requests under Resources. Next, the Compute Instances. I will select the appropriate resource type, acknowledge the warning, and select the instance. It is possible to define if it will be placed on a different compartment. Leaving empty, the compute instance will be created in the same compartment. If I had a dedicated VM host for the instance, I could select in the next field. The VNIC mapping, where the VMs will be paired with the destination subnet and network security groups. I will select the appropriate subnet and finish adding the instance. I will have to do this again as I have two instances, and once the compute instances are added, the next members to be added are the volume groups. As I have one volume group for each instance, I will have to do that twice. Once I'm done with the Ashburn members, I will switch the region to Phoenix and add the members there. Because the database is being replicated, there is already a replica there. It will be included in the Standby Protection group. The instances will not be added as this is a cold standby DR. Once the members are added to the DR protection groups, a plan can be created. The full-stack disaster recovery service will introspect the members and add the required tasks in the correct order. Because of this introspection and the intelligence behind the scenes, it was not necessary to add the instances and volume groups to the Standby Protection group for this code Standby DR. Let me show you how a plan is created and what happens. To create a plan, I have to go to the Standby DR Protection group. In this demo, I'm already in the Standby group in the Phoenix region. In the DR Protection group details page, I will select Plan and click on the Create Plan button. After I select the plan name, I will select the plan type, depending on the scenario I'm planning for. In this scenario, I will choose Switchover. When the Create button is pressed, Full Stack Disaster Recovery Service will introspect the members and it will determine and add the required plan groups and steps. After the creation, when I click on the plan name, I can see the plan groups and steps. After the built-in groups and steps are automatically added, the user-defined groups and steps that handle the stack-specific requirements and not supported components will be added next. First, I will add the plan group, and within the plan group I will add a task. In this step, I will enter the step name, define the error code, the timeout in seconds for that step, and the region where it will run. Then there's the choice of where the script is stored. In this scenario, I have the script stored in the compute instances, so I will choose local script. Select the instance and provide the script parameters, containing the path and other execution parameters. The script can also be stored in object storage or as a function if a serverless execution is required. This first task removes the compute instance from the load balancer backend in the Ashburn region. As I have two instances, I will add another task that will take care of the second instance. I will also add plan groups and steps for other tasks required for this scenario. They are related to the database credential wallet, the application setup, and attaching the new instances to the load balancer in the Phoenix region. These steps are similar to the first plan group and tasks that I added, and there is no value in showing their step-by-step execution, but it's important to mention as part of the whole process. Now that you are aware of the jump, let me skip to the next part. After adding the user-defined plan groups and steps, it is time to set the proper order for the plan groups. In the plan group list, using the Actions button, it is possible to work on the order and set them accordingly. After completing the order adjustment, the DR plan will be complete, ready to be tested and executed. In this demo, you watched from start to finish how the full stack disaster recovery service was set up for our demo scenario. Now, jump to the next demo to watch the pre-checks and execution of ADR plan. Thanks for watching and see you in the next lesson. Hello and welcome. This demo starts from where I left in the previous demo. I finished setting up my DR plan, and now I will show you how the pre-check and execution of a plan look like. As in the previous demo, some sequences might be played at a faster speed or trimmed to exclude waiting time. Let me jump back in the OCI console to get things started. Here in the OCI console, I will go to the list of the DR protection group and select my standby DR protection group. In my case, it's the one in the Phoenix region. Clicking on the group name, I will be directed to the details page. On the top part, there will be a button named Run Pre-checks. Pre-checks are utilized to continuously validate the compliance of a DR plan with the members and configuration of the associated DR protection groups. This helps ensure that the DR plan, which is designed to safeguard a particular topology, remains aligned with it. The purpose of these pre-checks is to perform ongoing DR plan validation and readiness checks. Click on the button, and I will be prompted to select the DR plan in case I have multiple plans, and also the option to specify a name. The ignore warnings is reserved for future use, having no effect today. Upon clicking on the Run Pre-checks, the pre-checks will be accepted and then moved to the in progress state. Clicking on the built-in pre-check to expand it, it will show the pre-checks list. Initially, they will all be marked as queued. They will change the status to in progress, populate the start date and time. Moving forward, if everything is OK, it will be marked as succeed, registering the duration and end time. During or after the execution of the pre-checks, it's possible to examine the logs. Clicking on the three buttons in the end of the line, I will select the View Log option for that. The log contains the details of the pre-checks, and if something goes wrong, it's where you can find the details. Running pre-checks often will ensure the plan is relevant and ready to be executed. It should be part of your readiness routine. On purpose, I stopped the replication of one of the volume groups and run the pre-checks again. If I'm running pre-checks as part of my readiness routine, it will show that something is wrong as per the failed status I have here. Expanding the built-in pre-checks, it will show what failed. I will check the logs to gather more details. Here I can see that the pre-check could not find a replica for the volume group. In the real world, this could have triggered a notification to investigate the problem and remediate the environment to reestablish the plan integrity and readiness. After fixing the missing volume group replication and running the pre-checks again, my environment is ready to execute the DR plan and perform the intended switchover. From the DR group details page, I will click on the Execute DR plan. As in the pre-checks, if I have more than one plan, I will have the option to pick the one I want. I also have the option to run a pre-check before running the plan. As I just ran a pre-check, I will skip that part. I will populate the execution name and click on the Execute DR Plan button. The execution starts, and the plan groups will be executed in the order that it was defined. The plan steps of each plan group will be executed in parallel. As the execution advances, it is possible to watch the state of each plan group and its tasks. Using the three dots on the right hand of each plan group name, it's also possible to check the logs during the execution. The execution can vary depending on the size of the environment and how complex the plan groups and tasks are. I will skip to the end of the execution and save some time. After 21 minutes, the full stack was switched over to Phoenix. The plan did not include deleting the Ashburn instances, but opening a new tab and navigating to the load balancer in that region. It is possible to see that the instances were removed from the backend set as indicated in the plan. Switching the region to Phoenix and accessing the load balancer public IP, the MuShop application is accessible as a result of a successful switchover. This second video concludes our demo on the full-stack disaster recovery service. I hope that looking at the demos of component setup and the plan execution will help you understand how the full-stack disaster recovery service works and how it could benefit you. Disaster recovery is not a fun activity, and we always hope that the plan was properly elaborated. But even the perfect plan is worthless if the execution is faulty. The full-stack disaster recovery service helps you ensure that the execution will go as planned, giving you peace of mind and one less thing to worry in case of a disaster. Thanks for watching and see you in the next lesson.
Welcome to this demonstration on moving a VM between OCI regions using full-stack disaster recovery. So let's get started. I'll take you to the OCI console, and currently I am in the Phoenix region. So very quickly I will create a VCN. I will name it Demo VCN, and this is going to be the CIDR block. Click on Create VCN. I'll also click on Create Subnet, Demo Subnet. This is the CIDR, and I'm okay with public subnet. Click on Create Subnet. Okay, so you see that the subnet is currently provisioning. Okay, so the subnet is now available. Now let me create an instance, and I will call it demo instance. I'll keep everything as default. Select this particular existing virtual cloud network and this subnet.